Good morning. We're going to talk about 2.6 or rational functions and their asymptotes. So today we're going to talk about domains of rational functions. We're going to find horizontal, vertical, and then oblique is actually going to be next, that 2.7 from your textbook, but we're going to focus on horizontal and vertical. So what defines a rational function? A rational function is anytime you have two polynomials in fraction form. So that's all that really defines to make the function rational. So there are a bunch of key features of rational functions, including your x and y intercepts, and then your asymptotes. So I'm going to consider this function for the following example, and then you'll work examples similar to this. So if this is the function I'm looking at, x squared plus x minus 2 over x squared minus x minus 6. What you're first going to want to do is factor the numerator and the denominator. The reason for doing this is you can simplify a rational function, and then it'll help you in the long run finding x and y intercepts as well as asymptotes. So when I go ahead and factor this leaves me with x plus 2 times quantity x minus 1, and then the denominator is x minus 3 and x plus 2. So notice these x plus 2's are the same, and I can actually cancel them, leaving me with a simplified version of f of x is equal to x minus 1 over x minus 3. So this is definitely the first step you want to take in anytime you have a rational function. So let's start. On A, we're going to find the y-intercept. So in order to do that, you're going to find anywhere where x is equal to 0. So this sounds pretty complicated, but it's actually a lot easier. So knowing f of x is the same thing as y, what I can do is just insert a 0 in for my x value. So this becomes 0 minus 1, 0 minus 3. Well, I know 0 minus 1 is a negative 1, and 0 minus 3 is a negative 3, leaving me with the answer of 1/3. So I found my y-intercept to be at 0, 1/3. What if I had an x-intercept? So just like finding, whoops, it's supposed to say y-intercepts. Oh, no, it's not. Just kidding. This is supposed to say x-intercepts of linear and quadratic functions. All you're going to do is you're going to take your y value and set it equal to 0. So again, a little bit the opposite of y-intercepts. So as a hint, you can always set just the numerator equal to 0. And I'll show you why. So if I take my simplified version of my function and I want added a 0 in here, what's going to happen is I'm going to multiply both sides by the denominator, so this x minus 3. These will cancel. What happens when I say 0 times x minus 3? This leaves me with nothing, right? So this just leaves me with 0. Therefore, you could have from the get-go just said, what makes x minus 1 equal to 0? And you would have added 1 to both sides, and this would have given you 1. So either way, these are true. This is the reason why this is true, okay? But that means my x-intercept is at 1 or 1 comma 0. When I'm talking about holes, these are a special case. So holes only exist when the numerator and the denominator have a common factor. So this is why it was really important to factor as opposed to just leaving it the way that it was. So this is no longer a vertical asymptote or an x-intercept because this will actually create a hole. So if I had a graph and I had a line, there would be a hole and then it would keep going. That's what it means by a hole. So if I remember about my original function, I had these x plus 2's and I canceled them, leaving me with this simplified version. So this x plus 2 means there's a hole where x plus 2 is equal to 0, or at x minus 2 is actually a hole. Now this isn't necessarily negative 2 comma 0, but it could be. Okay, so that means wherever my graph is, there will be a hole where x equals 0. Sorry, a hole where x is equal to negative 2. So there is a hole where x equals to negative 2 for this specific graph. So here's where we get into vertical and horizontal asymptotes. Vertical asymptotes are vertical lines, wow, that the graph or the function approaches but does not cross. So you're going to be thinking about, here's your graph, And if I had a vertical asymptote, so I'm thinking of something up and down, my graph may have a vertical line at x equals 2. So my graph may look like this and like this. So I'm approaching that line, but I'm not actually touching it. So how do I find that? That's the real important part here. I'm going to take my denominator and set it equal to 0. Now what I have to remember is if there is something in the denominator that cancels with the numerator, okay, that means I have a whole. So I cannot assume that anytime, just like the previous one we looked at when I had a whole, that x plus 2 is a whole, not a vertical asymptote. So again, factor is what you want to do. If I remember my original function, f of x is equal to x plus 2, x minus 1, x plus 2, x minus 3. These cancel, meaning a whole, not a vertical asymptote. So my vertical asymptote is only dealing with this x minus 3. So I'm going to take that x minus 3 and set it equal to 0. Well, I just add 3 to each side, and that means that at x minus 3, there will be a whole. And I can't scroll down. So this means there is a whole at x equals 3 at that entire line. And then when I talk about a horizontal asymptote, so again, a horizontal asymptote is a horizontal line, wow, interesting, where the graph approaches and usually does not cross. So these are a little bit different from vertical because sometimes they're really just suggestions. They don't actually always restrict the graph like the vertical asymptotes do. So the thing about a horizontal asymptote is that they actually have 3 different scenarios we may encounter. So if the degree of the numerator is less than the degree of the denominator, you will always have a horizontal asymptote or an HA at the x-axis or where y equals 0. Now, if my degree of the numerator is equal to the degree of my denominator, this means that I'm going to say y is equal to a fraction consisting of my leading coefficients. And we'll look at that because that's a little confusing. Now, if my degree of my numerator is greater than the degree of my denominator, this is not a horizontal asymptote. This is actually what they call a slant, and this is in 2.7. So we'll actually talk about that next block. But so you're really going to spend all your time on these first 2. So if I think about my horizontal asymptote from my previous function, right, I had my x plus 2's, I canceled those because that meant a whole. So if I look at my function x minus 1 and x minus 1, these x's are my leading coefficients. They're both up to a power of 1. So anytime my degree is equal to the degree of the denominator, I'm looking at that leading coefficient. Well, they're both 1 over 1. Therefore, I have a horizontal asymptote at y equaling 1. Now, if this was something like the numerator was less, so it was something like x over x squared, this would be the situation like number 1, where you would say that you would have something y equaling 0. Okay, but that's not part of this problem, but that's just looking ahead. And then finally, what if I wanted to find the domain? So these are going to help you when you have vertical asymptotes and holes. Will help you find where your domain is restricted. So I cannot have x values that are equal to -2 or 3 because -2 is a whole and 3 is a vertical asymptote. Outside of that, everything else is free game. So you can write your domain as x not equaling this, or you can say this in interval notation. So from -infinity to -2, there's something, but it's not existing there, so I put a parentheses. In union with, again, that -2, but then I go to 3. Or put a parentheses again because 3 is not included. And then I have to include any number between -2 and 3, but not including 3, and then any number after 3, but not including 3. So that's including that 3.0001 in my domain. So what I want you to do now is I want you to pause the video and I want you to look at those remaining 6 problems, and I want you to attempt to find your x-intercept, your y-intercept, your vertical asymptote, horizontal asymptote, and your holes. Now, if you want to go above and beyond, and you can find your domains as well. I'm gonna put those answers up, so if you go ahead and pause your video